Standard 1.8, compare sines and cosines of angles using less than, greater than, or equal to. Let's take a look at our first example here. Sine of 70 compared to sine of 80 degrees. First thing we want to do is figure out where these two angles are. And in order to compare them, let's choose a circle of a fixed radius. I'm not going to change the radius of that circle. So 70 degrees and 80 degrees, we're looking at points on terminal rays of the same circle. So 70 degrees is around there, 80 degrees is around there. And when we're comparing sines, we're comparing the y values of points. And so which point has a larger y value? Well, the higher up a point is on a graph, the larger y value it has. Since the point on the blue terminal ray is higher up than the point on the red terminal ray, the sine of 80 is bigger than the sine of 70. Or in other words, the sine of 70 is less than the sine of 80 degrees. Let's compare cosine of 120 degrees and cosine of 130 degrees. When we're comparing cosines, we're comparing x values. So let's take a circle. We can assume it to be a unit circle if you wish, but it doesn't have to be. And let's find out where 120 degrees intersects the unit circle, which is right there, and where 130 degrees intersects the unit circle, which is right there. Now when we're comparing cosines, we're comparing x values. The point that's further to the right has a greater x value. And so the red point is more to the right than the blue point, so the red point has a greater x value. And so cosine of 120 degrees is greater than the cosine of 130 degrees. We can also look at angles in radians. So sine of 13 pi over 7, let's figure out where 13 pi over 7 is. And this time we're comparing the sine of an angle with the cosine of the same angle. 13 pi over 7 is equal to 1 6/7 pi. So we're almost all the way at 2 pi. Here's our circle. And here is our angle. I'm just going to graph the terminal ray here. It's at 2 pi. Now what's bigger? The sine of that angle or the cosine of that angle? Well, the sine of the angle is negative because the angle is terminating in the fourth quadrant, but the cosine of the angle is positive for that same reason. And so a positive value is always larger than a negative value, and so the cosine in this case is larger than the sine. Our last example, sine of pi over 3 and sine of 2 pi over 3. So pi over 3 terminates in the first quadrant. 2 pi over 3 terminates in the second quadrant. Here is our circle. And so what has a larger y value, because we're dealing with sine? The red point or the blue point? Well, the red terminal ray is really a reflection of the blue terminal ray and vice versa. Both of them are equally distant away from this x-axis, and so both of them are equally high up. And so both points here have the same y value, which means their sines are equal. This was standard 1.8, comparing the sines and cosines of angles.